In lesson 17, we explored the remainder theorem, which gave us this interesting relationship between the remainder when we divide by x minus a and the polynomial evaluated at a. So p of a and the remainder when we divide by x minus a are actually the same number. So it's a powerful tool that we can use to help us determine if binomials are factors of polynomials. So number one here says, let f of x equal x cubed minus 6x squared minus 7x plus 9. Divide f by x minus 3. So we're going to divide f by x minus 3. I believe last time, in the last video, I ended with reverse tabular, which means I will use long division this time. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. We change our signs to subtract. Those add to 0, and I get negative 3x squared minus 7x plus 9. And we start over. Well, negative 3x times x is negative 3x squared. Negative 3x times negative 3 is positive 9x. Change my signs to subtract. That becomes 0. I'm left with negative 16x plus 9. And one last time, negative 16x times negative 16 times x is negative 16x plus 48. Change my signs to subtract, and I'm left with positive 9 minus 48, and going to my calculator just so I'm sure I'm right is 9 minus 48, negative 39. So when I divide f of x over x minus 3 is equal to x squared minus 3x minus 16 plus remainder over divisor. So that's what I get when I divide. Now, how do I check my work by finding f of 3? Well, let's find f of 3. That's 3 cubed minus 6 times 3 squared minus 7 times 3 plus 9. How does this help me check my work? Well, let's see what we get. 27 minus 6 times 9 minus 21 plus 9. 27 minus 54, negative 21 plus 9. And now when I add all those together, add slash subtract all of those together, using a calculator so you don't make any mistakes, you get negative 39. How is this helpful, and how does this use the remainder theorem? Well, notice that our remainder is what we got when we found f of 3. So I divided by x minus 3, which means plug in x equals 3. Whatever x equals 3 is, whatever f of 3 is, when you plug in that 3 to the function, that's the remainder when you divide by x minus 3. So this does check out because my remainder was negative 39, and when I plugged in x equals 3, not x minus 3, x equals 3, I got negative 39, so it does check. Remainder theorem is a powerful, powerful tool to check division. Number 2, is x plus 1 a factor of this polynomial? Explain your reasoning. So before we had the remainder theorem, to check if something is a factor, we would divide. And looking at this, I'm saying, oh my goodness, could I divide? Yes, but mathematicians are lazy, so I don't want to have to divide this this degree 5 polynomial. That would go on forever, and I would probably need another piece of paper. So we're going to use the remainder theorem. We're going to plug in x equals negative 1. When I plug in x equals negative 1, that will tell me my remainder. So 2 times negative 1 to the 5th, minus 4 times negative 1 to the 4th, plus 9 times negative 1 cubed, minus negative 1 plus 13. Again, at this point, you can just type it all in the calculator. Negative 1 to an odd power stays negative. Negative 1 to a even power becomes positive. So minus 9 plus 1 plus 13. Let's see what we get here. 13 plus 1 minus 9 minus 4 minus 2. I got negative 1. Got negative 1, which does check out. So what does this tell me? This tells me the remainder when we divide by x plus 1 is -1, because that's what I got out there. So whatever that output is, that's my remainder when I divide by x plus 1. So the remainder when we divide by x plus 1 is -1. Since the remainder is not 0, x plus 1 is not, it's not 0, so it's not a factor. You're only a factor if your remainder is 0. So the remainder theorem is very, very powerful here because it saves us lots of time from dividing. And you should do this anyway, but because it says explain your reasoning, you need a nice, beautiful, in this case, I wrote 2 sentences. It won't hurt you to write 2. 3. Which of the following binomials is a factor of x cubed plus 3x squared minus 10x minus 24? So which of these binomials is a factor? Well, guess what? I could divide 4 times since it's a multiple choice question. I could divide by x minus 1, that's a waste of your time. Use the remainder theorem here to help you out. So I'm going to check x equals 1. Plug in x equals 1, see if I get 0, because factor means I have a remainder of 0. Plug in x equals 2, see if I get 0. Plug in x equals 3, see if I get 0. Plug in x equals 4, see if I get 0. But guess what? That also takes a lot of time and is something I don't want to do. So here's how our calculator actually does this question for us. So on your calculator, go and graph that polynomial, x cubed plus 3x squared minus 10x minus 24. If I graph it, there it is. It's that cubic polynomial. We can't see all of it because of the window. But look at the zeros. The zeros are at 3, -2, and -4. The zeros are at x equals 3, x equals -2, and x equals -4. If those are my zeros, which factor which of these binomials must be a factor? Well, I know I get x minus 3, x plus 2, and x plus 4. So what's the factor? X minus 3. Because I had a 0 at x equals 3. Another way you could have done this is by looking at the table and seeing when I plug in what was the first number we were plugging in there? A 1. When you plug in a 1, you get -30. You get a remainder of -30 when you divide by x minus 1. You get a remainder of -24 when you divide by x minus 2. There's that 0 I was looking for at x equals 3. So because x equals 3 is a 0, x minus 3 is a factor. Your calculator is a very, very powerful tool in this case. And finally, number 4, the function f is defined by a polynomial. Some values of x and f of x are shown in the table below. What is the remainder when f is divided by x plus 2? Well, I don't know what the function is. I just know I'm dividing it by x plus 2, which means I'm going to check f of -2. Check f of -2, because to see what the remainder is when I divide by x plus 2, we plug in a -2. So I go to -2. What's my remainder? The remainder, using the remainder theorem, so let's say using the remainder theorem, we know f of -2 is the remainder when f is divided by x plus 2. Therefore, the remainder is -42, since f of -2 equals -42. That value right there is my remainder. It's a very, very powerful theorem to check your division and to see if things are quickly factors or not, because you get to avoid some of that division by just checking, by inputting a number and checking its output.